Login accepted.
Hi everyone, my name is Przemek and I'm going to talk about full text search with Elasticsearch. And I work at Allegro, so I'm going to use Allegro as an example. So let's start with a question. What is this? Obviously it's the Allegro web page. And what is this? So some people might say that this is the Allegro web page, but without the search bar. But it's not only that. It's also your worst nightmare. I don't know if you ever tried to find lamb wool on Allegro without the search bar, but I haven't, and I know that I'm not going to do this ever. And basically, this is the thing with the internet right now. There's just too much information, and we wouldn't be able to navigate through it without proper search. And people actually knew that a long time ago. So I found this video on YouTube with Steve Jobs explaining search. And well, it seems like nothing fancy, but if you look at the date, it's 1988, and it's 10 years before Google was founded. So it's pretty impressive, actually. And he's explaining how they built a search engine for a library and how you can search for books. And just look at how the world changed during the last 33 years. So, like right now, you can just take a search engine, configure it, and use it. And back then, I can only imagine how many millions of dollars were put into this operation. Okay, so we know that search engines are widely available, right? And imagine your grandmother asks you to build an online store for her, the same one that asked for the lamb wool before, because she's very skilled and very productive, and she can basically knit anything, like shoes, t-shirts, swimsuits, and jackets. So she asks you to build a web page for her, because you're good with computers, right? And actually you are, so you can do it. And you decide to create the page yourself, and you start wondering what search technology to use. So maybe there's something that's already made, right? That you can just put into your web page. And you start searching, and you can see that there's at least 6 of them. It's not bad. And there's some Elasticsearch, some Solar, and you keep looking, and it turns out that there's really a lot of them. So you should choose one very carefully. So some time passes, and you choose Elasticsearch, so surprise. And good thing about those search engines is that they're built basically on the same foundation. So there's this Lucene library. It's used for information retrieval. It's used for creating the index, and the search engines use it for running the queries. But it's just a detail for now, because we're going to focus on the Elasticsearch itself. So let's move to our online store project. We want to build a store, so we need to have products. And in order to have products, we need a place to put them. And such a place in Elasticsearch is called an index. Index is like a database table, more or less. It can be, but it can be perceived as one. And then we need the mapping. And mapping is something like a schema. So a definition on what is going to exist in the index. So let's see how we can create this mapping. Like this is a simple example of a query. We're going to operate on queries here, on HTTP requests, because I want it to be language agnostic. There are APIs in other languages, but let's focus on just the requests in JSON. So you can see that there's the number of shards, number of replicas, but we don't care about this for now. We don't have a cluster yet, let's say. We have one field, and the field type is text, and text is like a usual type for strings. And text means that this is going to be analyzed and divided into separate words, separate phrases, more on that later, and this field will be searchable. So in our case, the index will look like this. I used a full URL here just so you can see that I'm using the local instance with 9200 port, so the default port for Elasticsearch. You can actually use Elasticsearch as a service if you don't want to maintain it yourself. They offer such a system, or you can just subscribe to it. And we're going to have a few fields here. Most of them are going to be text fields. There's one integer field, price, and note that is of type keyword, and keyword means it's not analyzed. It's stored just like you entered the text, and it's not indexed, so we will not be able to search with this field. All right, so we created the index. So now our store looks like that. It's an empty shelf. There's nothing in there, so maybe let's add something. So how do we add it? We use an HTTP request. It's at the bottom of the screen, actually. So we used the products index, and /_doc means that we want to insert a document, and we used a post request. And there's the list of products. There are 6 products, so 2 sweaters, a shirt, 2 swimsuits, and 1 winter coat. All right, so our shelves are full. That's great. So now that we have the index and the products, we can actually query it and see how it goes. So just to mention about Elasticsearch documentation, it's actually very extensive and very nice documented, and there are a lot of available queries. So we are going to focus only on the full text queries, but you're free to explore their documentation, and there's many others. All right, so maybe not a query, but just 2 simple requests to start with. There's the underscore mapping, which just gives us the mapping, and it's exactly what we saved, so no surprise here. And there's the count query. It tells us how many documents there are. And now let's actually use the search request for the first time. So we are searching, but we're not searching for anything specific. It's only a GET request, so it just returns everything that is in there. And all of the products wouldn't fit on the screen, so I just kept first and last so that you get kind of like a gist of what is in this index. So we can see that there is the source, so the document we saved, and some other fields. And I'm going to mention that there's the score field. That's pretty important. Here, all of the documents have score of 1 because we're not asking for anything specific. But if we were, higher score means that this document matches the search query the best. So let's actually search for something. Let's search for a sweater. So we're using a match query here. So this is like most of the Elasticsearch operations are executed. You have this hierarchy here. First, we say that we want a query, then a match query. Then title means that we are asking the title field specifically, and query means the query text. Okay, so we're looking for a sweater, and we get 2 sweaters. Great. Let's move on. And now there's also the multi-match query, which is interesting because it can match multiple fields. And here we're matching against title field and any field which may be more than one that end with brick. So in our case, it will be fabric. But if we had more fields that end with brick, they will also be queried. So here we can see that we get the shirt because it's in the title, and 3 products made of lamb wool, and among them 1 made of lamb wool shining in blue. So that seems nice for now. So let's actually stop for a moment and think how it works. Because if we had just a regular database index and we typed in sweater, it wouldn't return any actually it wouldn't return any results because we don't have any product named sweater. Sweater is just a part of it. So we need some kind of other way to analyze and index the documents before we can query them. And how Elasticsearch does it and many other search engines is an inverted index. So let's go through an example and see how it is stored. So we have 2 documents. This can only be 1 field in a document, but let's say this is the whole document. So there are 2 sentences. In the summer, the quick brown fox jumps over the lazy dog. And the second one, the quick brown fox jumped over the lazy dog, exclamation point. All right, so how does an inverted index look like? And it looks somewhat like this. I mean, it may look like this. It may be a little different, but the structure remains the same. So why is it called inverted? Because in an actual index, the value of the field would be the key, right? And the other information would be the value. And we could query the key, but we would need to know the actual value of it to retrieve it quickly. And here, the key are the words. Actually, they don't have to be words. They can be phrases, like 2-word phrases, but let's focus on words right now. And we store the information on the documents in which those terms are contained. And we can wonder if this is fine, if this is actually fine, because just look at the word, THE. There are 2 the words. One starts with a lowercase t and one with an uppercase t. And shouldn't they be treated the same? And the answer is maybe, but we don't know that. Because let's think about an example of a word who and the World Health Organization. I mean, it's spelled the same, but it's something different. So maybe we don't want to make all the characters lowercase, but maybe we do. And in case of an online store, it's almost sure that we do want this. And the same thing applies to the dog with the exclamation point. We probably would like to delete that, but not necessarily, because maybe we want to do some sentiment analysis or something. All right, so let's move on to another query. We want to find a sweater with long. And we get 2 sweaters, so that's fine, but we also get the winter coat with hood and shirt with short sleeves. And we probably don't want this since we wanted a sweater with long something. And but there's the with word, and from the search engine's point of view, with is just like all the other words. So if it matches, it's okay. We're going to find it. But maybe we don't want to. I mean, we as the creators of the search experience, let's say, maybe we don't want this. And actually, those words like with, a, and, of, they're called the stop words, and it's a known subject, and there are ways to just ignore those words. So there, the stop words can just be removed, and first I'm going to explain how the queries and the documents are analyzed before going into the index. So first, when the document comes in, it goes into the character filter. So right now, the document is just a long string. It's a long string, unprocessed. There's a lot of garbage in there. Probably we need to clear that out. So we can have the character filters, and character filters can replace or remove characters out of a string. So that's good, but it's still just a big string, and we need words or phrases. So we need to split this string into words or phrases, which are called tokens. And this is the tokenizer's job. And there is just one tokenizer that takes a string and returns a list of strings. And the actual standard tokenizer that is used in Elasticsearch is actually well documented, and it's pretty complex. Like, it's not only divides by white space, but also by some characters that are known to split the words in sentences. And then there are the token filters, and token filters are pretty much the same thing as the character filter, but they work on tokens, so or on words or phrases, and they can replace words, they can remove words, and they can add words. Okay, so let's move on. Actually, let's get back to the stop words. And there's a way to define the stop words in the analyzer. So you can see that I added an analyzer, custom stop words underscore hehe. This is on purpose. This is so that you know that this is completely created by us. It's not out of the box. And it's defined just underneath as a custom analyzer. And we provide the information that it's a standard analyzer, so the one that we used before, but with a custom list of stop words, so that with will now be completely ignored. So just a remark, if you do it in production, there are a lot of ready stop word sets divided by language, so you can use those. But here it's just one, so that we get how this works. So now when we ask for a sweater with long, we get 2 sweaters. So that's what we wanted. And another thing is the synonyms. Like in Poland, a portable cassette player and Walkman are exactly the same thing. And we can configure that in Elasticsearch. So we're looking for a crocodile in our index, and it doesn't exist because there's no such clothing item as crocodile. But turns out, and don't quote me on that, but turns out that crocodile is a sweater. It's the same thing. So we want to configure that. And again, we need a custom analyzer. But this time we added the synonyms, underscore hehe. And the synonyms are a list of strings, and each string are words separated by commas. And the rule is all of the words in the string mean the same thing. So, for instance, here we have the crocodile, fence, and sweater, and it's completely the same. And tree, corgi, and swimsuit are also completely the same. I guess I didn't mention that if you define an index, if you provide a new definition for index, you need to re-index all of the elements. So you need to remove all of the elements and create a new index. And so see how it works. Right now we're asking for a crocodile, and we get 2 sweaters. So grandma will be very happy with that, I'm sure. And let's move on to some more advanced features of modern search engines. So namely suggestions. We know that suggestions are a very, very important thing. We use them, and they helped us not starve many times. And but in all seriousness, we know that a good suggester is something very complex. Like how do we know that this thing I typed in Google, and by the way, it's not photoshopped. It really works like that. How do we know that it means what it may mean? I mean, there are many ways, many metrics on how to think that one word may mean another word. So I'm just going to show you one of the suggesters, the phrase suggester, and it's a simple suggester. But as you can see, we didn't use the query element here. We used the suggest. It's a little different. So say we would like to find a winter cat because we think that such an item exists, and we want to find it, and we want to buy the cat. We specify that we want to query the title field, and we want to highlight the words in the EM HTML tags. So what we get here is 0 hits, because unfortunately our grandma doesn't need winter cats, but she does need winter coats. So we get this option. So there is winter coat, and in the highlighted field, the code is even surrounded by the HTML tags that we provided. So that's pretty nice. All right, so let's move on to something that is really useful in e-commerce sites, blogs maybe, and well, Google obviously. So autocomplete. This is really useful if you don't really know what you are going to type, but you want to see what your options are. So it's connected to the suggesters as well. It's actually a type of suggester, but it can be configured really easily in Elasticsearch. So let's say we're typing. In the end, we want to find swimsuits, but all we typed so far is swims. So we don't get any hits because there's no such thing as swims in our index. But we would like to configure the index so that it suggests that maybe we want swimsuits. All right, so the only thing you should do here is specify the field as the search as you type type. And this is out of the box. I didn't create that. But this is this is actually a shortcut to a suggester. Suggester optimized for speed, and suggester that creates not only the title fields, but a few n-gram fields. And an n-gram field is like a 2 gram or 3 gram. So for example, if we have a one-piece swimsuits, the 2 grams would be one piece and piece swimsuit. And the same thing applies to trigrams, but trigrams are 3-word phrases. All right, so we need a specific query to get the autocomplete, namely the bool prefix query, so that the word begins with what we have here. And we're querying the title and the 2 subfields of title, so 2 grams and 3 trigrams, and we get 2 swimsuits. So that's nice. We can display that as the autocomplete suggestions right now. And and that's it for the queries. And I'd like to point out that nice thing about Elasticsearch is that it's part of an ecosystem. So Elasticsearch is like the heart of it, but you also get Logstash and Kibana, and they are Logstash is for logs obviously, and Kibana is for viewing those logs or for creating dashboards of many sorts. So it's actually nice because with those products you can have like a big part of your metrics and observability stack in your systems, and you know that they're nicely integrated. And there's also another thing, the observability agents. It's called Beats, but they didn't want it to add to this acronym because it would destroy the elks. All right, so that's it. If you have any questions, I'm here. Please share your feedback and vote on the presentations. Every script and request I made here are in my GitHub repository. Requests are in the form of exported Postman collections. And the script is in Python. All right, thanks. Okay, there are any questions? Okay. The question is if we use Elasticsearch for product search in Allegro. If you mean the main search, we use Solar and a lot of custom built stuff. But for example, in ads, like the products that are displayed above the search results, we use Elasticsearch for them. And for many other smaller things as well.
Why have you decided to use Solar?
I guess the decision was made a long time ago and maybe Elasticsearch wasn't there yet. I'm not sure.
Another question about those suggesters. You mentioned in this full text oriented presentation. I'm wondering because I only abuse and applies when the query returns no results, yeah?
Yeah.
They suggest some options. But then you can somehow manage from Elasticsearch query the stack order of those suggesters, which ones will apply priorities of those suggesters. Yeah? But first come with autocomplete, maybe later try to figure out other things, if it's possible. Yeah? Because for example, requires do it custom.
So the question is if we can stack suggesters with priorities, right? So one way that you can achieve that is to have a set of fields that contain the same value but have various suggesters. I'm not sure if you can provide multiple suggesters in one query, but maybe that's possible. I haven't tried it. So I guess I encourage you to take a deep dive in the documentation, but you can definitely ask the same field with different suggesters. Yeah. Yes, exactly. All right, thanks.